So let's learn about the meanings of quantifiers. So there are two basic facts. This thing, for all x, that's how we say that, for all x, symbolizes the long English phrase, each thing is such that. And then we say for some x symbolizes at least one thing is such that. So for all x, it means the same thing as in English, each thing is such that. Some x, or for some x, means in English, at least one thing is such that. So for example, let's say we have the sentence for all x, fx in our English, in our logical language. So there are two parts to that. There's the fx, that means it's a frog, and there's the for all x, and that means each thing is such that. So literally, if we see for all x, fx, that means each thing is such that it is a frog. A much simpler and shorter way of saying that is everything is a frog. So that's if we were asked to symbolize everything is a frog, we would do for all x, fx. Similarly, if we have some x, fx, then the fx still means it's a frog. The existential x means something is such that, so the whole thing, something is such that it is a frog. Shorter, easy way to say that, something is a frog. So we have some simple variants. So if we have for all z, fz, doesn't matter that it's x or y, right? In English, we don't talk about the variables. So each thing is a frog, everything is a frog, all things are a frog, or whatever we mean by if. We have some s, fs, something is f, there's an f, at least one thing is f. So if we have this backwards e, right, what's going on? We have for some x, fx, there's a thing such that when x refers to it, gx is true. So at least one thing is such that it is g, something is g, at least one thing is g, there is a g. So if we have g means is green, then we ask, is this true or is this false? In particular, we ask, is there at least one thing such that when x refers to it, gx is true? So like when x refers to this, gx is false. When x refers to these, gx is false. When x refers to this, gx is false. However, there's at least one thing that is such that when x refers to it, gx is true, this, and there are actually lots of them, right? So there are many things, not everything, but many things where when x refers to them, gx is true, and that means something is green and the whole thing is true. Some x, gx is true. On the other hand, and this is not the way things are, but if it turned out that whatever x refers to, it's not green, that would mean there are no green things. It's not the case that something is green and some x, gx is false. So the way we ask, if we have an existential statement, is it true or not, is we take the gx and we carry it around to each of the things in the world. And that would take infinitely long because there are infinitely many of them. But that's what we would do, is we would carry it around and to each thing and say, are you such that g is true of you? And if we ever get the answer yes, say, aha, yay, we're done. We know that it's true. If we keep going and we never find one, then we know that it's false. Now, at least that's if we were verifying it in the most straightforward, simple way. There are other ways to do it, as we'll see with our derivation rules. But that's how we would think about it. Gx carried around to each thing in the world. If the answer is ever yes, gx is true of it, then the existential statement is true. The answer is always no, then the existential statement is false. Universal works the same way, more or less, except it's universal. It's all instead of just some. So we could say everything is g, each thing is g, all things are g. So let's say we have for all x, gx. Then we have to ask, is each thing such that when x refers to it, gx is true? So we carry gx around to each thing. We say, is gx true of you, and of you, and of you, and of you? And if the answer was always yes, then everything would be green, and we'd say for all x, gx is true. But if the answer was ever no, then it would mean that something wasn't green. It'd be the thing that's making that when we use x to talk about it, gx comes out false. Say it's not the case that everything is green, and for all x, gx would be false. So let's look at some examples of symbolizing with straightforward symbolizations with the quantifier in the symbolization module. So let's suppose we wanted to symbolize everything is oval. Over with the scheme, we would have the scheme would tell us what predicate letter are we using to symbolize this oval, and we have the convenient letter O. No variables over there, and variables will never show up over there. We could have names, but we don't need any for this symbolization. So we just have the one predicate letter telling us what how we're going to symbolize is oval. So we look at this, we say everything is oval. So this every, that is what kind of quantifier? It's a universal quantifier. That's how we're going to symbolize it. Every, all, each, those get symbolized with a universal quantifier. So we're going to bring up our menu and we're going to choose univ gen because this is a universal generalization in English. So we are going to say choose univ gen and it's going to put in that for all x. Now here we would type x is oval. And then we would say this is atomic and we would type O and then we put the x. And we need to make sure that the variable we put here matches the variable in that quantifier. Otherwise, our symbolization will not be right. We need to have it that the variable next to the quantifier is also the variable that shows up in the atomic formula. That's not required for it to be grammatical, but it is required for it to be an accurate symbolization. So that's the two steps. First, we put in the quantifier using univgen or existgen. And then we have to figure out, okay, so that's going to put in the quantifier, and it's also going to choose a variable for us, and we'll always choose x first. And then we write in what the atomic formula is, and in this case, it's x is oval, and that turns into OX. So that's how we would symbolize everything is oval. Let's look at 2.6218, and you could try this one. So again, we're going to get our menu, and this time we're going to choose, well, let's look at it. It's something is oval, so that's a generalization. It's not about any particular thing being general. It's a general statement. It says at least one thing, something. So something, that's we symbolize with our existential quantifier. So we're going to choose existgen. And again, we put x is oval. Right? We're saying there's at least one thing that is what way? It is oval. So we use the same variable, and then we write out is oval there. And then we're going to turn that into an atomic, big O for the oval, or is oval, and then X for X, and we have our symbolization. So that's how we do our most basic symbolizations. You choose the right quantifier, either universal or existential. It's going to put in the quantifier symbol in a variable. Then you write in the text box. You would never have to write in the text box, but what you would write in the text box is X is whatever. The verb is, you write x and then whatever verb we have. So here we have the verb phrase is oval, so we write our variable x, then the verb phrase, and then we symbolize that, and that's always going to be atomic for the very basic ones. So it's O for is oval, and then x for the x, and we are done. So hooray.